In this problem, we'll see how to graph a linear inequality in two variables. Let's look at our helpful hint. Remember to use a dashed line for the graph of the boundary line if the inequality is written with a greater than or a less than symbol. Here's our inequality that we want to graph, and the first step in graphing an inequality is to first graph the boundary line. Now, as the hint suggested, because I have a less than symbol in the inequality, I'll be graphing that line with a dashed line. So first we're going to graph the boundary line, and to get the boundary line I change the less than symbol to an equal sign. So we're going to be graphing the line 4x minus 2y equals -6. Now to graph that line I could use a table of values. I think for this one I will write the equation in slope-intercept form and use the y-intercept and the slope to graph the line. To write it in slope-intercept form I need to solve it for y. So I'm going to subtract 4x on both sides. When I subtract it on the right side, I'm going to write the -4x first, and then the -6. And then dividing both sides by -2, I get y equals, dividing the -2 into both terms on top, I have 2x plus 3. So this is the equation for the boundary line, and again I want to graph that line using a dashed line. This equation is in slope-intercept form. I have the y-intercept at 3, so across the y-axis at 3, and the slope is 2, or 2 over 1. So from the y-intercept, I go up to right 1 to find another point. And I'm going to do that a second time to get a third point on the line, up to and over 1. So there's my boundary line. The second thing to do is decide which side of the line to shade, and the shaded part will indicate our solution set. We need to find a test point, and we can choose any point to test as long as it doesn't lie on the line. 0, 0 is probably the easiest point to test. So if I let x be 0 and y be 0 in our original inequality, I'll want to find if that's a true or false statement. Letting x and y both be 0, I get 0 on the left is less than -6. And that is false. 0 less than -6 is a false statement. So that means I do not want to include 0, 0 in the solution set. In other words, I want to shade the other side of the boundary line. So there's our graph for the inequality. Every point on this side of the line is a solution to the inequality. Now remember the helpful hint when graphing linear inequalities. If you have a less than or greater than symbol in your inequality, you'll graph the boundary line using a dashed line.